Let us understand a very effective strategy to make the trinomial a perfect square by finding the right value of k. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll try to understand how do we make perfect squares when we are given trinomials with some unknown parameter like k in these equations. So the question here is, find the values of k to make trinomials a perfect square and then solve the equation. So it has two parts. One, find the value of k to make them perfect square and then find the solution of each equation, right? So our focus will be to find the value of k, and then you can continue and complete the question to find the solution also. Perfect? Now this is indeed a very important question. Many times it could be challenging for students to answer these questions. The variety which you see in these 8 problems is pretty good. These are the questions which have come in past 5 years of test papers. You will notice that k has different positions, right? In these two, right there in the middle, as a coefficient of x, and then here as a constant. Perfect? And then we have the ones at the end. In between, I have taken an example where I like you to practice and solve. I hope that makes sense, right? In case you want to learn from me, feel free to send an email directly. You can also check our website for the latest updates. Now, before we begin the solution, let us try to understand this concept of perfect square. What does it really mean? So, perfect square is something like this. If I have x plus y whole square, right? This is called perfect square. It means there's only one factor, right? Since it is quadratic, it is multiplied twice to itself. So it is like x plus y times x plus y, right? Clear? So that is how you normally see it. So multiplying with x both the terms, that is to distribute, what do we get? We get here x square plus xy. And now let us multiply y with both of them, right? So what do we get? Well, we get y times x. It is good to write xy, since these should be written in alphabetical order. And then we get y square. Makes sense? If you write yx, that is not wrong, but next step, you need to apply the commutative property of multiplication, rewrite in this form. Now what do you notice? You do notice that the terms in the middle, xy, they can be combined. And so we could write x plus y whole square, which we are calling as a perfect square, as x square plus 2 times xy plus y square. You get the idea. So basically, that is how the 3 terms are related. Now the middle term is twice x and y. You get the idea. So the term which is the x square term, square root of that comes here and square root of y comes there. Perfect. So you see this common thing, x and y. That helps us to answer this particular question. So I hope you have a good visual look, and now it should not be difficult for you to answer these 8 questions. Perfect, right? So let's begin by taking them one by one. The very first one here is what for us? It is x square minus kx plus 9 equals to 0. Now x is given as x square, that's perfectly fine, okay. And 9 is what? 9 is 3 square. So we know that we can make it a perfect square. The only thing is that the middle term should be what? It should be twice x and 3, right? So the middle term should be 2 times, I'll write 3 first, and x. You get the idea. Only then this will be a perfect square. Correct? So that clearly means that if you equate them, that means what is k? K is equal to 2 times 3, right? K is equal to 2 times 3. Makes sense? I think it does. And so we get our solution. And the solution is that k is equal to 2 times 3, which is 6. Correct? You get the idea. One more thing I'd like you to notice here. Well, I have told you what is x plus y whole square, and then example was something like x minus y whole square. You see that? So x minus y whole square, if you expand, will give you minus in the center. That is it. Otherwise, it is exactly same. Now you realize one thing, that working with this in the center, we could have both the answers, right? We could have plus or minus. And therefore, getting back to our question, very important conclusion, that we could actually write k as what? We could write k as plus 6 or minus 6. You get an idea. Now, many students miss on this part, and that is the reason why in the question we have values of k. Does it make sense to you? 90% students only will write either plus 6 or minus 6. Very few will write plus minus 6. You get the idea. Those who get right, I'm telling you about those students, right, who are close to that. So you clearly see that this particular expression, which was x square minus 6x plus 3 square, when you compare with the original equation, you can see that k should be 6, right? But why not minus and plus both? Even then, it becomes a perfect square, right? So that makes sense. So both ways, it becomes a perfect square, right? So we get two solutions from here. One is that we get x plus 3 equals to square equals to 0, and we also get x minus 3 whole square equals to 0. And both will give you different answers. One will give you x equals to minus 3, the other one will give you x equals to plus 3, depending on which value of k are you taking, right? So if you take minus k, you'll get this equation, correct? So let me rewrite. So if I take k equals to minus 6, I get plus here, right? Because that becomes plus. But if I take k equals to plus 6, then I get minus. Does it make sense to you? So therefore, be careful, write both and then solve the equation and give both the possibilities depending on the value of k. Perfect. Now with that, let's move on and take the next question. Next question is exactly similar. We have x squared plus kx, right, plus 16 equals to 0. And clearly, 16 can be written as 4 square, right? And we already have x square here. So the center term is what? Center term is 2 times 4 times x. Now, the center term is 2 times 4 times x, but if I write 2 times minus, will it work? I think it will, right? K could have both the values, right? So see here. If you look at it, the equation x square plus 8x plus 4 square equals to 0, right? Let me write equals to 0. And x square minus 8x plus 4 square, which is 16, you can write, right? Let's write 16 here for 4, right? Both are the perfect square depending on the value of k. So the value of k in the first one is what? It is k equals to plus 8, and in the second one k equals to minus 8, right? So accordingly, you get two solutions. One is x plus 8, x plus 4 whole square, k equals to plus and minus, right? Here the k is 4, and in this, k is 8 here. Yeah. So in the first factor, you get x plus 4 if k is positive, and in this we have x minus 4 equals to 0, right? So you see we get two different solutions. So we have x equals to minus 4 here and x equals to plus 4 there. That is very important to understand. I hope you're getting it, right? So note, we have two solutions for k, right? That will give you two different equations, and therefore for each one of them you have to write the solution separately. Perfect? Makes sense? Good. Now let's move on to the next question, which is, now k is in the position of a constant. So we have 4x squared minus 8x plus k equals to 0 and x squared minus 6x plus k equals to 0. How will you do it? Let's try it out, right? So now 4x squared minus 8x plus k equals to 0. So I can write this as 2x whole square, right? Minus the center term should be what? It should be 2 times, and what is this? Can I make it a perfect square? Yes, I can, provided I have square root of k square here. Do you see that? Square root k square will give you k in this position plus k, and therefore I could write here 2 square root k times x, right? So we got these two terms, 2 times 2x, right? Times 2x. I have to write 2x, right? Correct. So be careful. 2x is your a, right? So that is how you will be. So it becomes 2x whole square minus 2 times 2 is 4 square root k x, right? And we have square root of k square equals to 0. Makes sense? Now in this particular case, we have only one solution, right? Now what is that solution? Minus 8 should be equals to minus 4 square root k. So I could write this as, comparing, I get 4 square root k equals to 8, right? So what is k? So that gives you that square root k equals to 8 by 4, which is 2, and that gives you k as 2 square, and so k is 4. Clear? So k is 4 in this case, right? Now, substituting k as 4, we can write this as a perfect square. So let's continue, right? And find the solution of this. That means the equation now can be written as what? So we can write 4x squared plus minus 8x plus k equals to 0 as 4x squared minus 8x plus 4 equals to 0. You see that? So that is to say that k is equal to 4, right? And see, now you can write this as a perfect square, which is 2x minus, it comes from here, 2 whole square equals to 0. You get the idea? Equate this to 0. So we have 2x minus 2 equals to 0, or we have 2x equals to 2, and that gives you what? That gives you x equals to 2 by 2, which is 1. So we have one solution, which is x equals to 1, correct? So we found that the k value is 4 and x value is 1 in that case. To make this as a perfect square, does make sense to you, right? So that is how we should be doing it. You could actually factor out 2 here, right? And then also solve the question. So 2 square will be factored, basically. X will still be 1. Correct? Right. Now I'd like you to do this question on your own, right? So try it. So that is, take it as a test. Is that clear to you? Perfect. Now let's take the next type of example. Well, here again, k is in the center. So I'd like you to try these questions, right? And find the value of k, right? So note, in this case, note, k may have 2 values, right? First. Second, solve both the equations and find their solution. Very important, right? So take this as a test. And now here we get to the last, where k is right there in front of this equation, right? So we have kx squared plus 10x plus 1 equals to 0. Let us see how do we solve this. So kx squared, we could write this as square root of k x whole square. Do you see that? And then center term will be what? 2 times, now we have square root of k times x, and here we have 1, so times 1, right? Plus this is 1 square equals to 0. Correct? So this could be the perfect square. So here clearly, what is the value of k? Compare it with 10, right? So we have, just compare with 10. So we have 2 square root k equals to 10. So square root k equals to 10 by 2, which is 5. And that gives you that k equals to 5 square. So k is equals to 25. Is that clear to you? So if k is 25, the equation is what? Well, the equation will be 25x squared plus 10x plus 1 equals to 0, which can be written as 5x plus 1 whole square, right? Equals to 0. Equated to 0, so we have 5x plus 1 equals to 0. X is equal to minus 1 divided by 5. Is that clear? So that is how we'll write the solution. So this is very important to understand, that if k is in this position, you could factor and write it as a square. Square root of k whole square, right? And the center term being 2 times a, b, right? And so you get your solution. So I hope this concept is clear, right? So once again, we began with the concept. So any equation which is kind of x squared plus 2xy plus y squared equals to 0 can be written as x plus y whole square equals to 0, and if there is minus here, it becomes minus. So if the k value in between, you put it minus, even then you can make a perfect square. You see how we got 2 answers when k was right in this center, right? So with that, we actually solved all these questions, and we found that these have 2 solutions, right? Even these, right? Where k is in the center. So it is very important to practice with these questions, as students have missed such questions a lot, or when they get it in test, they actually get wrong answer or incomplete answer, and that is why I am repeating it here. I hope that makes sense. Feel free to write your comments, share your views. If you like and subscribe to my videos, that'd be great. And you can always check my email if you want to learn from me directly, or our website for the latest updates and some discount programs. Thanks for your time and all the best.